Let's take a look at some problems that deal with hydroboration oxidation. So it says here, predict the products for the following reactions. The first one comes from the book. It's 8.16b. Anyhow, so I have an unsymmetrical alkene, and in the first step I'm treating it with borane THF, and in the second step I'm treating it with hydrogen peroxide and sodium hydroxide. And the important thing is that in terms of regioselectivity, I'm adding the hydroxyl to the least hindered carbon because it's an anti-Markovnikov addition, but I also have to remember that I'm adding the hydrogen and the hydroxyl in a syn fashion, and that means that they're being added to the same face of the double bond. So if I start by drawing my carbon skeleton, so if I draw my hydroxyl going up, that means that the proton is going to be going up like that. And if I draw the product of the syn addition from the other face of the molecule, I'll have the hydroxyl pointing down, and I'll have my proton pointing down like that. And if you're asking yourself, aren't these just enantiomers of each other? The answer is yes. So these are enantiomers of each other. If I take a look at the second one, so this one already has a chiral center in it, so that's going to make it a little bit more interesting. So again, first step is treating it with borane and THF, and second step is treating it with hydroperoxide and sodium hydroxide. You have to memorize these reagents. You have to memorize the order. So let's draw the skeleton out here, and let's put our wedge like this. So I'm going to end up adding the hydroxyl to the least hindered carbon, which is this one I've highlighted in red here. So if I draw it with the hydroxyl pointing down first, that means that the hydrogen will be pointing down, and my methyl group that's here is going to be pointing up like that. Conversely, I can get the syn addition from the other face of the molecule, where the hydroxyl is going to be pointing up like this. My proton is going to be pointing up like this, and then my methyl group is going to be pointing down like that. And the relationship between these two compounds is that they are diastereomers. So they're diastereomers of each other. And the reason why we don't just get enantiomers in this case is because we already had a chiral center in the molecule.